All right, we are live. Hey everyone, welcome to another Game Dev live stream. My name's Charles. This is Infallible Code, and I'm joined today by Jason Story. You all know him and love him by now. Today we're going to be looking at some code. Again, we're going to be taking a look at a game I've been working on. You may have seen it in some of my previous videos, my little sheep game that I'm making for my wife. And we're going to take a look at some strategies that Jason and I use to design for change, design for flexibility, maintainability, and all that fun stuff. So we'll talk about what that means in a little bit. But before we get started, just wanted to mention that I'll be giving away a copy of Quantum Console thanks to the developer. He's a great guy. You may have also seen him commenting. Recently did a video on Quantum Console, and he was gracious enough to hang out in the comment section and answer a lot of questions. So check that out, definitely. And I'll be dropping a link in the chat for that around 15 to 30 minutes into the stream. If you did not catch this live, you're watching this VOD right now, don't worry. This particular giveaway, I'm going to let this go for a week. So I will announce the winner on Twitter on July 4th at some point. Maybe even July 5th, just because it's a holiday and I know people are busy. So just join in there. I will drop a link. It's like we've done it in the past. It'll take you to a website. All you have to do is just enter your information. I won't keep any of that. It's just so I can contact you when I choose the winner. So yeah. So how you doing, Jason? It's been a while since we did one of these.
Yeah, pretty good. You know how it is, keeping busy with everything going on.
Oh yeah.
A lot of working from home. So
Yeah. It's been interesting. Been taking a lot of time to study and learn. I think I went through a period of a couple years where obviously doing the channel, I'm teaching, and I really do think that teaching is one of the best ways to learn, or really like solidify your knowledge of anything. But I hadn't really gone through a period where I was like, okay, I'm going to dive in on some subject. So yeah, I've been doing that. I know you do that pretty often anyway.
I do. I pick a topic every so often. This for the next, I think, month or so, I'm really interested in the concept of game and level design. So I'm slightly veering away from the programming. I do that all the time. So I thought for a bit of fun, I'll learn a lot more about scene composition.
Yeah, become a more well-rounded developer. Oh, you cut out there for a second.
Why not?
But by the way, Jason's internet he's getting some better internet where he's at. But
they're literally installing some good internet, so don't worry. This is hopefully be one of the last times that I'm fading in and out of existence.
Yeah, that'll be good. Yeah, so that level design stuff is really cool. You were sharing with me a video, and so we'll see when we switch over to Unity that I have like a little sheep level, and it's just bare bones, and a lot of it is just I'm copying what I have an asset pack, and I just copied what was in the asset store as far as the examples go. They always give examples, but I watched a video that Jason shared with me about level design, and I can link that in the chat later. But you'll see at the end of the stream, one of my commits is after I've applied what I learned from that, and I don't know, I think it looks pretty good. So cool stuff there. All right. Well, without further ado, let me just check on the chat. I see a lot of, as always, familiar faces. Urizor. I always butcher that. I'm sorry, but thank you for being here. 01. What's up? What's up, man? How's it going? Vakaral. Hey, cool. And everyone else who's here. When does Jason make his YouTube channel? He has one.
There's just no videos on it yet.
Yeah, there's a great playlist though.
Yeah, I know. I'm actually kind of at a point now where I've got a bit of free time, and I should really start putting out some videos. I might just sort of bite the bullet and make a few 5-10 minute videos just to start it off in the next month or so, but we'll see. No promises.
As long as you're consistent. That could be.
I will say though, if anybody's interested, I'll just share one thing. Is it possible for me to share my screen with this setup, Charles? I can send a screenshot and you can share it either way. So my point is, if anyone's worried that I'm not at least somewhat thinking about the YouTube channel thing, here's a little image that shows me the ideas I've been playing with for stuff to do videos.
Send it over to me. I'll pull it up on the screen. Switch over to the game view here, Unity view.
So there you go. This just gives you an
Oh boy, yeah, I've seen part of
Example
this.
of a few things I could possibly making videos about. Yeah, so just to show that I'm working on a few things. It's just I haven't quite
Oof.
gotten the I haven't quite gotten around to which parts I'm going to attack or which parts I'm going to make videos on yet.
This
But
is
you know,
this is Jason's mind map. This is what's going on in his brain at any moment.
pretty much. So
Oh
there's just a
wow.
few ideas. So don't worry. At some stage, I'll start turning these little topics into articles or videos. I just haven't gotten around to it yet.
Pathfinding. That's something I've been wanting to dive into next. As we'll see in what the code we're looking at today is like I did some grid-based movement, and the next thing I want to look at is how can I do like A-star pathfinding, with that implementation, things like that. So that'd be cool. That's cool. Cool, man. Yeah. Oh, and I can see the more game developy type things here. Item
Yeah,
design.
you can see the big cluster in the middle is currently what I'm working on, which is a lot of stuff to do with player psychology and how to design interesting abilities and possibility spaces and that kind of stuff.
Nice.
Yeah.
Alrighty then. Well, let's dive into the code. Again, I'll be dropping that link for the the giveaway soon. But for now, let's talk about some code here. So, again, this might look familiar if you've seen some of my latest videos. If not, be sure to go do that. But this is a game that I've been working on for my wife. It's kind of a long story, inside joke between us, but it's a little sheep game. And right now, it's very simple. Just press play here. It has very basic movement. And I'm using DoTween to do like this hopping jump, and you'll see that in the code. But basically, what I did here for this movement, I don't even know if this is going to work. I don't have a box collider on this, but I'm using ray casting to do movement and obstacle detection. Let me go ahead and just drop a grid on this. Is that going to be too complicated? Yeah. So fence. Not a grid. I'm going to drop a box collider here. Make sure this works. Yeah, there we go. All right, let's see if this works. So you have your sheep, hops around. Now it looks like it's grid-based movement, but you're gonna see in a moment that it's technically not. It's just I'm hopping and I'm being sure to only hop in one world unit at a time. I'm not actually like adhering to any grid, but I would like to adhere to a grid. So let's just take a look at the code here. Switch on over to Rider. Though I know this question always comes up in the comments. What is this thing that I'm using here? How does it know that I'm using this script is being used in 4 Unity assets? And why is my name appearing in all this craziness? This here is an IDE called Rider. And as much as I wish that I am not sponsored by them. But I do highly recommend it. It has great integration with Unity. And I know a lot of people probably use Visual Studio and maybe have heard of ReSharper. It's the same concept, made by the same company. This is just an entire IDE that is basically what ReSharper gives to you. And there's so much more. All right, so you'll see in the code here, just the top, we're in the sheep class, and the sheep class is what's responsible for controlling the sheep. Now, you won't see any input in this because if you go to the player class, I've kind of delegated that responsibility. In its update method, it basically just takes some input based on the WASD keys and then calls .move on the sheep. So it has a reference to a sheep, which it pulls from its own game component, and then it delegates that movement into sheep. So if we click into there, you can see it's not too fancy. I have a state variable that just makes sure to keep track of whether or not the sheep is currently moving. If it is, we don't want to allow it to move twice.
Well, just a brief pause here, because the one thing to note when talking over a lot of architecture like this is that we're kind of skimming over a lot of ideas. Like it may seem simple to say, oh, we take direction and we pass it to move, but the thing is, there's actually a lot of very interesting design decisions that have gone into just that sort of seemingly where do I draw the line decision. And so it's worth noting the idea of having a sheep with a move method that receives a direction isn't arbitrary, because what that lets us do is, if you think about it, anything can generate a direction. So you could take a sheep, put it in the scene, give it another script called, sheep that always moves left, and you just put a method on sheep that always generates a left vector or left direction. So the idea is that sheep only knows how to move. It doesn't decide where to move, and something else will give it that decision. So in this case, by having that separation between player and sheep, means you have a player who is generating input, which is being turned into a direction, which is then handed to a sheep. And that way, the player is simply generating data, and then that data is handed to the sheep. And so you could have anything generate that data, and it means that you can have different characters controlled by a player, or you can have different controllers like AI, or you could have the player control multiple sheep at once, and it doesn't affect either or, right? There's no rewriting required to expand that functionality. So it's worth thinking about where your division lines are in your application. And right now, a thing that moves and a thing that generates input, which happens to be a player, are two separate entities that work together in this instance to work to the same effect.
Right. And we can see that I actually have an NPC class that has some very rudimentary logic that just basically looks for the player and has the NP sheep move towards the player. And you can see here that, again, yeah, it just calls sheep.move. So there's definitely, this is like what you call, I guess, a system boundary. Where you decided that, like Jason just said, the decision to where to go is decided completely different system than the sheep, who just is responsible for moving itself in world space.
And you're familiar with this already if you've used either rigid bodies or character controllers, because they follow the same kind of concept, which is a character controller knows all about surface collision and calculating normals and all that stuff that it needs to do. And your job is to hand it a vector and say, go that way. And you don't have to do all the math to calculate and reposition your vector to make sure it's aligned with the surface or anything else. Like, you just hand it a vector and it knows how to use its own internal logic to turn that into a movement. And so in the same way with rigid body, you hand it a force and it will figure out how to aggregate that force, apply it as an acceleration, and do all of the work for you. So as long as you figure out what's the bit that's isolated, that's likely to change, you can make your code a lot easier to work with. And in this case, yeah, it's effectively a sheep character controller is what you've made.
Yeah. So that's a good point. Thanks for bringing that up. And if I gloss over anything like that, definitely want to stop and make sure we talk about that. Another weird thing you guys might see is this direction. That was another design decision. And I explained it, I think, in the previous stream, but just for those who didn't catch it, it's just a class that encapsulates the idea of moving north, south, east, and west, all the cardinal directions, actually. And then I've just encapsulated, what that actually means as far as moving one position in world space. So that allowed me to get away with a lot of this grid-based movement, quote unquote, because I'm not actually using a grid yet. So if we go back to the sheep, I'm actually showing this code like a little deeper into its history, because when I first wrote it, it was prototypical and it was not designed for change. It was just, I was always slammed into this one move method. But I've since gone to the trouble of actually encapsulating that into this method called getDestination. So getDestination makes a couple intelligent decisions about obstacles, and then allows the sheep to move in the way that I want it to move. So we can see here that, again, I've even encapsulated a little bit more. So it steps through, it says, hey, we're going to get this is the destination where the sheep will go. So right now it just starts at transform.position. So in the worst case scenario, the sheep is going to stay put. So first it checks, hey, is there an obstacle? Is there not an obstacle in the vertical direction? If there's not, then we'll go ahead and we'll add that to direction or destination. Same for horizontal. And then it just returns the destination. And then if we look into obstacle exists, we'll see that's where I actually do the raycast. And I know, Volkerl, you asked, is there a specific reason I did a raycast other than using a quick box overlap? I'm just more familiar with raycasts, and I didn't think too deeply on it, but that probably would have been a better solution. I'm aware of the box overlap thing. I've never used it. So this is my first time really doing anything like 2D. So yeah, I just slammed in the 2D raycast. And also because
a side note with that is you've got a function called obstacle exists that takes in a direction and returns a bool. Right now, the strategy for that implementation is a raycast, and you could literally encapsulate those two lines and return something that does a box overlap instead, and it would be pretty easy to change. So until designing systems like this, you don't have to get it right first time. You just have to make it work and have it be available to change. Like it doesn't matter which implementation you pick, as long as you're aware which lines of code are likely to change, you support that going forward. So for example, right now, the change from using overlap boxing versus using a raycast versus using basically any other implementation is those two lines, and everything else in the entire system still works the same. So it doesn't matter what you pick. It matters that you make sure that it's easy to change if it's a system that's likely to change.
Yeah, so I guess this would be strategy number one for making your code resilient to change would be even in a single class, try to isolate certain logic that could be a change point. Like for instance, when I wrote this, I'm depending on Unity's raycast, built-in raycast, but I didn't know if this would always be the case, and even now, like if Volcarol came through and said, you know what, raycast is really unoptimized, and if I started noticing like some issues with my game running slowly that were caused by this, then I would say, okay, well, now I can figure out a way to optimize this, and maybe that box collider method or the box cast method is more performant, so then I could easily change it. So yeah, strategy number one, even inside of your own classes. Now, and with the funny thing too is that I made this decision based off of readability. I mean, granted, it's obviously I'm reusing the same logic twice, so I didn't want to repeat myself, keep it dry. But also, I mostly just want this code to be easy to read. But what I got out of that was the ability to easily change it as well. So,
yep. And a couple of notes on that. One, for people who are curious about the symbol on line 49. So basically, that is just the standard not equals. But if you're using certain fonts, there's a concept called font ligatures. And you put a space between them to demonstrate that, yeah, so it's those two symbols, but when you merge them together, they change. And that's effectively, some fonts have sort of nicer or simpler ways to indicate certain symbols. And in this case, this font, yeah, this case, there's a lot of stuff we do repeatedly in code that starts to get a bit visually heavy, so some even sort of merge them. So that's just a personal preference. And then on the point of encapsulation like this, I did a stream a while ago, and I made a method in a class called log, and all it did was call debug.log. And somebody asked me, why did you do that? It's already debug log. You can already call print. There's no reason to encapsulate it in something else. And the point I was making was that at some point later, I changed that from being a log print to being a text mesh pro displaying on a label. And when I made that decision, I had one place to change it inside of my own print function, rather than doing it in like having to go through the 10 or 12 places that I wrote debug.log and replace them all out. So it's not that it may seem arbitrary to put a wrapping around a method that you know you're using, but if you know it's a likely point to change, that one little decision to say, you know what, I'll just make one method name for it, wrap it, and use it in all these places, because I know it's an explosion of like, it's going to be used in 30 places. If I change this, I change it in 30 places. Otherwise, I use my own method and then I change it in one place. It's just very small decisions that make your life easier.
Yeah. Yeah, exactly. Yeah, so the strategies there again, you want to isolate the code that will potentially change into, methods is one strategy. What we're going to see in a moment is another strategy is to actually push that into classes, which I guess that's the strategy pattern. You call it that, where basically you're taking, I guess algorithms and putting them into individual classes that, maybe implement an interface so that you can just talk to the interface, and then the implementation changes based on the needs of your project. All right, so without further ado, I think that's the next thing we're going to talk about, because as I wrote this code, I thought, this works. And this was written during a period where I was trying to find the fun, where Jason and I were just trying to knock out features as quickly as possible. Originally, I had wanted to do some grid-based movement where there's an actual grid in memory that holds the position of the sheep. And, I would do obstacle detection in that way. But I had never really worked with grids in that way, and I didn't really want to go down that rabbit hole just yet. I wanted to get the thing working. I wanted to see if it was fun, and I mean, to be honest, it's just movement, so I know that's fun. But that was just for me. I wanted to say, hey, I want to get this little sheep hopping around the screen. I had never made a sheep hop, right? And again, this is kind of like an inside joke with my wife, but I always describe the game that I would make for her, and I would always say, like, she'd always say, I want him to hop. I want him to hop around the screen. So I was like, okay, well, let me just get that, let me get some brownie points with the wife real quick. And as you saw, we've got this do jump here, which is part of the do tween library, tweening library. And so we got that. But like I said, I want to do grid-based movement. So the next step is, how do I implement that? Well, implementing that's going to require me to refactor this whole class, right? So the first thing I wanted to do is, so that I made sure that I didn't break the the sheep logic was I needed to write tests. That was important to me, and I think it should be important to anyone that once you've established what your basic game mechanics or your business rules are, that you capture those in unit tests. For instance, one of the things that I wanted to make sure is that when the sheep got against an obstacle, was like rubbing up against an obstacle. I don't know how to. There's a better way to say that, but I wanted to still be able to move in the diagonal direction and still kind of move across, if that makes sense. So right now I was holding the diagonal keys and it was still kind of going down until it got past the obstacle. So I wanted to make sure that I captured those sorts of details. So let's switch up and go to the next commit. Here's another important thing I should mention as well. As you work on code, I highly suggest you use some sort of source control. Obviously, Git is the de facto standard, and capture every little bit of iterative work that you do in a commit. And so even if you don't push your code to a repository in the cloud, even if you keep this local, which you can do, I don't know if a lot of people don't know that, you can still commit. And now I can go back and I can see the history of the things that I did. So you can see here that in this commit here, I added collision detection. In this next commit, I updated to .tween Pro. And then in this next commit, this is when I wanted to go ahead and start doing some work on that grid implementation. I added test coverage for sheet movement, because I wanted to add test coverage before I did all my work.
So 2 notes on this while you're here. One of them, I'm really glad to see that you're following one thing that a lot of people that frustrate me when they use Git do, is Git is basically a snapshotting tool, right? It says take this folder at the state it's in, and make a copy of it so that I can always return to this state. And so when you're naming your commit messages, you are naming it as what it was, or what that snapshot, what you did to it. And so rather than naming it in the present tense, because that doesn't make much sense when you're saying, when you have stacked commits like this, if you name it in the past tense, you're saying what this snapshot added or what this snapshot removed, etc. So it's very clear, because of the tense naming between these different commits, what each one will do. So you can grab one of them and say, oh, this is the one where the collision detection was added, or so on. So so whenever you're using commit messages, I suggest previous using the past tense, but then also being very verb heavy. So fixed or refactored or implemented or encapsulated or renamed. That tells you what that commit did at the time at which you made it. And secondly, if you're worried about the effort involved in like setting up Git and doing all this kind of stuff, if you're using either Visual Studio or Writer, it'll do it for you. There will be a checkbox to say create a repository. And in the case of something like this, I don't know how you actually make your commits, Charles, but the way I do it is I just press Control T and write with the word commit, and it gives me a little pop up inside of Writer. And
Control T.
What's your search bar? The one that shows in the middle. Because I'm using the Visual Studio.
I have the shift.
So just that one there. Just type commit at the top.
Okay.
And press enter, and it'll bring up the thing. Type in your message, the commit, and it just commits whatever current message is there. So it doesn't have to be a laborious separate concept, right? Like you create a project, set it up with Git, and as Charles said, it can be local. It's not like you don't have to go to some kind of cloud service. It just means the folder you're in will maintain. So it's just a good place to start. Later on, make a GitHub and set it up there if you know how to do all of that. But a good starting point is just simply make sure that even on a simple project, commit regularly, commit in the past tense, and it's not that difficult to do to get in the habit of it.
Yeah, definitely. And I hesitate. It's a hard. If you've never used Git, I'm not sure what the right approach to learning it is. When I learned Git, I was very particular about wanting to learn all the command line commands and all that. And for a long time, I refused to use a GUI application. I would always do it from command line. I would open up Git Bash and do it like that. But with a tool like Writer, I mean, it's such a pleasure. You don't have to know anything about anything. All you need to know is, hey, you're going to make a commit. It'll all show up here, the changes you make. Like if I say, this is a change, you'll see that I have the change here. You can even do really cool things like this. You can go into your diff here and you can select which ones you actually want to include in a particular commit, which is, kind of more advanced, but you have the ability to actually commit on a line by line basis. But basically, once I've made this change, you can say added comments to the sheep class. You get the idea. And now, sheep class. And now you actually have this captured in time. You hit commit, it gets added to this list, this stack of commits, and you can go back to it whenever you want, as you saw that I just did. So yeah, highly recommend learning Git. And I don't know. I feel like, what do you think? Do you think people should go to the trouble of learning the command line so they understand what's happening behind the scenes, or do you think we're at a point with something like Rider where you can just kind of work with it at a high level?
I would say, depending on what you're doing, personally, I would say start easier. So there's actually like a GitHub app that's sort of a lightweight
you're right.
Git client, and that'll get you started with like 3 clicks, get you a repo, and do all of the setting up the remotes for you and stuff. And I think that's a good place to get you started with the ideas. And then once you're comfortable with it and you hit your first commit issues, then it's time to go down that rabbit hole. But I wouldn't say it's behind yet, and it's worth doing. I don't think it's a good place to start because it's unnecessary, right? It's one of those things where your goal is to make sure your files are safe, and then you go off on a tangent for a week or two learning.
Yeah,
like it's worth doing, but just being pragmatic about what you need to do is probably a better approach to start.
Yeah, that makes sense.
Oh, and as for for people talking about the names again in chat, so the idea is the commit you're making is a snapshot of what the code looks like now. But the reason I personally don't like, again, it's entirely preference. It doesn't matter whether you pick past tense or present tense or whatever, as long as you're consistent. It's just my personal preference past tense. But for example, one of the examples of chat is you could name a commit fixed tile map and add demo scene. And that's fine. That's a perfectly fine commit name. But the problem I have is that if you are reverting back to fixed tile map and add demo scene, that conceptually sounds like you're adding a fix to the tile map and adding a demo scene. When if it's fixed tile map and add demo scene, that means that sounds like you're going back to a time when you fixed the tile map and added a demo scene. It's a very subtle change, but it's one of those things where I think for people who are, when you've got a lot of commit messages with a lot of things going on, short, very present tense oriented can get a bit confusing as to, wait, am I doing this? Is this before that happened or after that happened? But past tense tends to imply when you pull this one down, it'll be the commit with which that event had occurred. But it's, again, very small, subtle things. It doesn't really matter that much. Just whatever you pick, same as conventions in code, just be consistent with the rest of your team.
Yep. Yeah, consistency is by far the most important. Unless your consistency is like you come up with some sort of numbering system, or like don't do that.
I can live with you putting like maybe an ID to a Jira reference or something if you've got if you're using some sort of task system or whatever, then fine.
I do that. I do that at work, and it's nice because when you get in there, you can actually click around. Like it'll actually take you to the build machine. If you're on the build machine, you can click. It'll take you to the ticket. So that's definitely good. But most people,
it's really good too. If you've got a really big build environment and you're using like the Atlassian suite and you're using Slack for Teams and all this kind of stuff, it can be pretty cool because what happens is when you make a commit message is automatically dropped into a Slack channel to update people on what's going on, which are paid for the item of the to-do list that you wish that you marked that you were doing. So people can look at it, see that you've done something, see that it's complete, click the link, which brings up your Jira board or whatever, which lets you look at what the item was, which looks at the time estimates, which looks at you can like really put it all together. And it's really good for a team that keeps everything in coordination.
Yeah.
But that's a lot further along and unnecessary compared to just getting it done. Like, very basics, just add Git, commit your last few files. That'll get you 80% of the way there.
Yeah, totally. I see a lot of comments about Unity Collab. I used it a long time ago when it was very fresh, and it was okay. Yeah, but to be perfectly honest, I see you can't even do branching. Branching is something I use pretty often. You can see I'm using branches here where I'll create a branch for each one of my videos because it allows me to go ahead and make the example project that I'll post to Patreon and not have to mess up my actual master branch. But even for like this grid-based stuff, if I wanted to do some experimental things but I didn't want to mess up my actual productivity, I could make a branch off where I'm just messing around with the code, and I can have commits being separately done there. But if I need to get work done on the actual project, I could still be uninterrupted there.
Yeah, and then there's other stuff too. Like if you've got a new person who joins the team and they're not familiar with the code base, it's often a good idea to just like copy the code base and call it, Martin's copy, and then just let them go nuts. They can delete stuff, add stuff, play with it, and it's a really good learning exercise. And then once you get into more enterprise stuff, again, there's this concept called Git flow, and Git flow is a particular strategy with which to apply Git branching that lets you extract out features, work on them, merge them back in, and keep a consistent golden path through your code. There's a ton of this stuff that gets really interesting and complicated, but again, it's not super relevant just to this stuff, I'd say.
All right, well, we are 30 minutes into the stream here, so I promised I'd drop a link for that giveaway. If you don't mind, before I do that, slam that like button or invoke the like button there, so that people can also get an opportunity to find this stream and then perhaps sign up for the giveaway as well. So I'm gonna drop this in the chat.
I will say just.
Yeah.
Yeah, and on a side note about collab as well, I do actually use collab, so I'm not I wouldn't say it's the devil's version as well. Just to put that out there. It can be a good tool depending on what you're using it for.
Yeah. I need to revisit collab actually, because I like the concept of it. I like that it's all in Unity, but I haven't touched it in a long time. And I see that it uses Git under the covers, so that's cool.
Yeah, in general, like it depends what you're like. In my case, I'll often work on client work where there's 2 to 4 of us on the team, majority artists, and I'll find that what works well for me is I'll have a little project that's just a C# class library, and I'll work on that. I'll have my own Git and my own committing for it, and then what I'll do is I'll copy the DLL into the main project and add that to the commit, and that lets the artists version their art and lets me version my code. And then the integration of code to art is also kind of versioned by the proxy whenever I add my own DLL and commit it. It might seem a bit redundant, but I kind of find that you don't want to muddy. It's happen at a different rate than code changes. And oftentimes they're the reason why you do it and the reason what you want to do with them are different. So putting them all together into one giant commit list, especially when you can't do branches, is a bit frustrating. So I find you can keep your code to yourself and then you can add in the bits that change,
Yeah. All right, we're going to move on here. Someone asked how long the stream goes for. We're probably going to go for about another hour. So we usually go an hour and a half. Yeah, as Dustin said. So, all right. All right, moving on with this story of my working on this game. I wanted to encapsulate I wanted to move my logic into a more grid-based movement, but I wanted to get tests first. So here you're looking at the tests that I created. And there's some decisions that I made in writing these tests. Actually, is this the latest version? Let me see here. Yeah. Am I on this one? Let me check this out. Let me make sure I got the right one. Yeah. Okay. So basically, you can see here that I tested for moving horizontally, moving diagonally, vertically into an obstacle, horizontally into an obstacle. And I don't want to go too deep into this, but the idea here is that I've got a test for each one of those use cases that I described. You see diagonal into a diagonal obstacle, diagonally into a vertical obstacle. So just wanted to capture all that. Let me let Unity reload here. And now you can see that in my test runner, let me make sure that you can see that because I know our faces are sometimes in the way. Oh, no, we're good. You can see my test runner down here in the bottom right. We can run those, save that scene up. And God willing, they'll pass. There we go. So these are slowly going to become more integration tests than they are unit tests, but we'll see that in a moment. So with that out of the way, with all that tested, now I can move on to the actual work. So that's just one thing I suggest as you go to refactor. Make sure you have tests for the code that you're going to refactor. So we can skip this one fixed tile map and create a demo scene. Here, extracted movement logic into its own class. So as you can see, I don't want to just dive into implementing grid-based logic. What I want to do first is move all of my existing logic out into its own class so that it's out of sheep. And the reason why is because we want to set ourselves up in order to turn this into an interface that our sheep class can talk to. And we'll see that in a second. So you can see here that I've created this physics 2D movement, and then I've stored it as movement. Then I attach it to the game object, and I grab it using get component. And then moving down to here's the move logic. You can see we still call get destination, but now we're calling get destination on movement. So I've taken that exact same code, that exact same function call, and I just moved it off and delegated that to another class. So all of that logic that was associated with it, the plumbing that we did, let's go over there. The plumbing such as, let me see here. Oh, I must have done some changes. Oh, I remember I renamed it to can move instead of is there an obstacle? But basically, it's the same idea. The physics2d.raycast is there, and then all that logic we did is pushed into here as well. It looks different because I didn't like, what was it called? Obstacle exists. I just felt that was weird. It didn't relay the message clearly. So I renamed it can move, which I think that's way more obvious. Like, can you move there? Okay, yeah. So that was just a design decision strictly for readability. That's all I did that for. But it's all the same stuff. So now that we've moved this into this physics 2D movement, you can see that I had to update my tests. So if we go to sheep test here, you can see that, oh, I actually didn't. This happened yesterday when I was explaining this to Jason. Because I added this type of physics 2D movement as a required component, now just by adding a sheep to a game object, that component will be added. So I didn't even need to change my tests. Everything is above board. So forgive me if I kind of glossed over that, if there's anything in the chat you guys want to bring up that you want to look at. But just the general idea here is we took existing logic and threw it into another class.
Yeah, so the basic idea, established from the start of this video, that when we make a character, in this case a sheep that can move, at the core level, something generates input. So we'll say gamepad, someone's pressing top left on the analog stick. Their intention is to move up and left, right? That's their up and left. That's their intention. So they can hand that to any character, and that character will figure out how, using its own internal logic, to move up and left. And so up until now, there has been one method for doing that, and that would be the particular method that Charles was mentioning, just adding a position to that. And so by encapsulating that idea into a movement strategy, it now that the pipeline goes, inputs generated, handed to a sheep. Sheep chooses his strategy, which in this case is the default one, and that will then move using that strategy. And this means that while the input provider can change, the characters themselves can change, but you can also decide to change what strategy a character uses. So the classic example from the Head First programming book is you could have a duck, and a duck can flap to fly. If you are a duck with a jetpack attached to it, it doesn't really matter, because at the end of the day, you're saying, hey, duck, here's the input I want you to take, here's the direction I want you to go in, and whatever method that duck decides to move is up to it. And so in this case, by keeping the same contract with the sheep character, you maintain that same logic you had before of decoupling input from the character, but by internally using a different strategy, you are giving the sheep the ability to change out implementation irrespective of either the input or the contract with the player.
Walker mentioned that he saw a bug with my movement. I was just trying to see if I could figure out what it was, but we don't have to dig into that.
I don't know, man. Test coverage, you should have this stuff locked.
I got the test. I don't know, the test seemed pretty good to me, but I missed something. It is possible. But all right, so we've delegated that. We've delegated the movement to this class called Physics 2D Movement. But of course, this is the thing that we want to change, right? I want to change Physics 2D Raycast to some sort of grid implementation that just looks at a position on a grid. So what the next step in this is, now I need to pull this Physics 2D movement and I need to derive an interface from it. So I have a commit for that, but I can actually show you what that would look like. So in Writer, there's the ability to, and I know guys don't want you to like cling on to this too much. You can do this by hand, but in Writer, you can actually do create, let me see, interface, extract interface. Extract interface is the word. So if we click extract interface, it's going to ask me, what do you want to be the members? And really the only members that I want to expose are get destination. That's it. Because can move, that's just some plumbing that this particular implementation has. So I'll go ahead and hit next. And then we can see now we have this, it's called iPhysics 2D movement. I shouldn't have named it that. Let's go ahead and rename that. Oops. what's the hotkey? There it is. We're going to call this eye movement because that's just how movement is implemented. So change that. So
As
now,
I said before, this is the movement strat.
Yeah.
Qualify as a thing that can move another thing. You have to, when handed a direction, figure out a vector. That's all it takes to be a movement implementation.
Right.
And in this case, our current one is the one underneath, which is the physics 2D movement.
Yes. So now we have this. It's implementing eye movement. So now in our sheep class, now what I can do is instead of having physics 2D movement be the movement variable, I'm just going to have it reference the interface instead. And this is actually part of the solid principles of actually writing to implementations. Mm-hmm. So we're going to go ahead and remove this required component for now, because now it can be anything.
And also, this very clearly represents open-close principle, because what this demonstrates is we now have a sheep where it's using a certain movement method, and we may want to change that. So it's open for that ability for us to change it, but it's closed for us to change the code itself, because all we have to do is provide a new strategy, and the actual implementation changes without the code actually changing.
Right. So in this case, right now we're filling it with this get component with a physics 2D movement, but at the end of the day, we can change that by really passing in anything that implements eye movement. So let's go ahead and move up the commit chain here. You can see where I created an interface for movement. And so let's check that out. And here's where I actually did have to make some changes to my sheep tests. Let me switch back to Unity real quick. It's probably going to need to reload. Okay, make sure that looks good. All right, perfect. Right, so let's go back to Writer, and then we can actually take a look at those sheep tests. And you can see this is probably a negative comment about unit testing, but like I said, these are starting to turn more into integration tests than they are unit tests, because realistically, I can start moving towards a place where I can write a test for physics 2D movement instead of writing a test for the sheep. Eventually, I'm going to move all of the quote unquote business logic, the real game mechanics that I care about, into their own individual classes. And as long as those classes are tested, then it really doesn't matter what sheep does, because sheep is just an aggregate of a bunch of different, will become an aggregate of a bunch of different implementations that it just delegates to. So that's just, I know some people will see this and be like, oh my gosh, look at that. Every change you make, you have to update your tests. And it's like, yeah, you're right. But eventually I'm not even going to need these tests, So I'm getting coverage and for right now. And then later I will just refactor them out, and I'll continue to have coverage moving forward.
There's different strategies too that'll avoid a lot of this complexity. As Charles will point out at some stage later, I no doubt, is things like the builder pattern and a few other things that avoid coupling certain issues.
How funny. In this case, I will show that next.
Like for example, one reason why tests can be a little bit of a pain at this stage of development is right now there's a test has three parts to it. It's the arrange, act, and assert. And the idea is get all the pieces together, choose what you're doing with them, and then verify the status as you expected after the action has occurred. And in a lot of cases, the range for the is the same thing. So in the case of testing whether sheep can move, you could arguably have a kind of a nested level beyond sheep tests called the sheep movement test or sheep direction test. You can encapsulate that. And the thing that's different is right now, I don't know if it's even true. Can you do setup and teardown in Unity tests, Charles? Do you know?
Yeah, you can. Yeah, you can.
Yeah, so conceptually, the idea is if you were acting on a movement system and a sheep,
oh yeah, I'm doing it right here.
Yeah, so you could effectively take those setup pieces of a sheep and a physics system or whatever and move it out, and you'd end up only having one or two lines inside of each test. Now, it's not necessary at this stage, but the point is when you get to the point you're like, well, what happens when I've got 500 tests and I change a line of code and I have to rewrite my tests? Well, that's a failing in writing tests, right? Once you get to that stage, there are strategies to avoid that happening. And that basically boils down to move as much of the same things we did earlier, move as much of the setup logic into one piece, just like I said before about the log versus debug log. And that way, if that changes, if you change your contracts for your interfaces, or you change the the way certain or whatever, you can do that in one place, and all of your other tests will be fine with it, because each test should only test 1 or 2 lines of code. So it is entirely, it can be, I'd say 90% avoided. I think the biggest issues is if you outright rewrite classes. And honestly, I think that's a fine case. It doesn't matter. If you get to the point where you're completely rewriting your code base, of course your tests will change because your requirements have changed. But up to that point, it's not as big of a problem as I think people think it is.
Yeah. There's oh man, I forget what it is, but I think Uncle Bob or Steve Martin, one of them, has like an example of how I think it's like accountants have to do like a double check on their books just to make sure. You know what I'm talking about?
Double account bookkeeping. That's Bob Martin's go-to. He likes that one. He says that if you treat programming as a craft, just like accounting would be, is accountants write everything twice and then make sure the balance is at the end. And if you care about your work as a programmer in the same way, because let's be honest, bad code can literally take lives. If you've if you've written code for written code that's supposed to be for calculating dosages for some medical application. I mean, I'm not saying everyone's in that situation,
right?
But if you conceptually at least acknowledge that code can be lethal, it's just good practice to treat it with a little bit of reverence and carefulness, you know. And if that's the case, then his argument is double account bookkeeping is the equivalent of you write your code, you write your tests. If they both qualify at the end and they both match, then you've got two sets of accounts to make sure that your code is doing what you expect it to.
And this may be a little woo-woo, but how many times have you come across a bug and it's stressed you the hell out? Like, I've had some really bad long nights trying to fix something. And, you know, I know the argument. I've heard this in my day job that isn't even game development, where we deal with code that is, you know, deployed to power companies, where it's like, hey, we're not making a medical app here. We're not trying to shoot something, you know, a rocket into space. Like, it's not going to kill anyone. So that's the argument for why should we waste all this time writing tests? But in that same situation, I've torn my hair out trying to fix something that, man, if I had just taken the time to test it, like, I would have never had to deal with some of the problems that I had to deal with. So for your own mental health, you know what I mean? Like, why not just take the time to craft your code? It makes you feel more confident about what you're working on. It allows you to really solidify the knowledge of the stuff that you're writing. It's I don't know. I really struggle to find any pro that outweighs the cons of the time you need to write those tests.
And to be honest, on a personal level, the reason I like writing unit tests more than anything else, it's a lot of people think it's dogmatism or being sort of particularly on board with everything must be perfect in code. It's not about that at all. What really benefits from my perspective is if you write unit tests, you have this checklist that your code works. And there's this whole concept of mental memory or mental RAM, where you've got a certain amount of things you can keep in your head at the one time. And making sure that, I have to make sure that the input still works, I have to make sure the UI still works, I make sure that the things still function. And every time you change your code, you have to go through this mental checklist of, just double check everything still does. It's going to fall by the wayside and something will break. But if you can put all that stuff in tests, then you don't have to keep it in your head anymore. When you want to verify that the code still does what it's supposed to, you press run tests and you end up saying, does the database call still work? Does the movement still work? Does the screen still draw? It's like, good. I don't have to mentally keep that in mind to check every time. And that freedom then gives you the freedom to play with your code. And this is one of those really interesting things that people don't realize is quite powerful, is what do you do at the moment when you come across an old method that either you didn't write, or that's part of an API that you don't know, or that was written so long ago that you don't remember what it does? Normally, you're afraid of it, and you don't want to touch it, because if you touch it, it'll break, and you won't know how to fix it. Now, having source control is one thing that'll let you feel comfortable enough to try playing with it, but you're still worried if you break it, you break the entire application. But if you had a suite of tests, you could feel more comfortable playing with that, double checking the tests, seeing if they still work, and you can actually explore that code without fear. And that's kind of the real benefit, in my opinion, of having tests for your code, is that you actually all of a sudden aren't afraid of unknown code anymore. It doesn't become this thing of, there's this big block of scary code I don't want to touch. It's more like, I can try and refactor. Like every change I make, that it still does exactly what it did before I changed the code. And this gets even more cool when you add stuff like continuous testing, where you could have a separate monitor running and all the tests run every time you click save. So you keep writing code, save, click writing, save, and you just, the minute anything turns red, you stop for a second, undo something, double check it turns green again, and try again. And you get this continuous cycle of guarantees that your code still works. Very, very cool.
Yeah.
Takes a bit of time to get used to that, but it's a cool situation to be in.
Yeah, I think it's worth it. It requires discipline, but something that a quote that I believe in is that discipline is freedom, because you have the freedom to do all the things that Jason mentioned. You can play around, you can set up another branch and try out new things and explore new avenues that you may not have previously because you were too scared to touch the code. So, all right. I saw mentioned in the chat builders, and Jason mentioned as well. So I'm going to show you. I skipped ahead one commit. We'll go back, but I wanted to show this builder that I created because I knew that I would want to create a sheep eventually that used the grid-based movement, because that was the whole point of this thing, is that I wanted to implement grid movement, and so I want to test for that. So I decided to create this builder. So you can see here, there's this. It's some static class called a dot sheep dot with physics 2D movement. So it reads so great. I need a sheep with 2D movement, or physics 2D movement. And how did I make that? I don't want to dive too deep into it, but if we go and take a look at what A is, and anyone who's interested, yes, I would make an un if it was a class that started with an A. If it was Apple, I'd make one called un, so I can say an apple. But basically, this returns a sheep builder. So if we go in and take a look at what sheep builder is, it basically, when you create a new one, it creates a game object and it stores it in this private game object member variable. And then as I add methods, so we have the with, and it takes in a component, I'm basically adding components to that game object. And then finally, there's a method called build, and that's where I finally add the sheep, and then I return the actual sheep. Now, if I needed to do more complicated stuff, like for instance, if sheep had some variables on it, I would have to do this earlier on. But in this case, I could get away with just kind of making a shortcut. And when you call build, you can add the component then. But as we can see, I've also added an implicit operator that casts sheep builder to a sheep. And what that does is it calls the builder.build, and that would return a sheep. So that's why I'm able to, and this is getting a little low level, but that's why I'm able to cast a sheep to a sheep. It's really casting the sheep builder.
I still don't know why you do that. I prefer sheep equals, and then not having to apply the
explicit. This.
Implicit. Yeah. Just because you have to do the cast anyway.
I think you're right.
To not have to. Yeah.
Well, it's all a matter of preference, but. You're right. You're absolutely right. That's one way to skin the cat. I'm just such a sucker for VAR that I always just do it instinctually.
On a side note, to answer, Rob has a question about how do you introduce tests to a large legacy project? Well, this may not sound like a very satisfying answer, but how one bite at a time. So the truth is, you pick a system, a smaller one preferably, and you say, right, this chunk of code, when I do this, it returns 4. When I do this, it returns 10. If I call this function, I should get a true. But if I pass in this information first, it'll return false. And you just write a test to verify that it works. Once you know that it works and you're comfortable, you can possibly try to refactor it a little bit, because now you're kind of safe with what it does. And then you keep doing that. Like, you don't have to look at it like an entire code base as, oh my God, this is a nightmare. Quite frankly, the Pareto principle, or the 80-20 rule, usually is in effect here. There is about, I'd say, 20% of your code base, which is mission critical compared to everything else. There's usually something that is your business logic, or the thing that, like, if this breaks, a lot of stuff breaks, and all of a sudden everyone has to stop working. We have to take things offline and start, like, panicking. But the rest of it, if there's glitches in the UI and stuff, and it doesn't really affect any data, it's probably annoying, but it's not the end of the world. So take the 20% that matter and slowly take pieces of it and just wrap it and very kind of comfortably, play with it. There's actually a really good book. It's literally called Refactoring. I forgot the...
For like enterprise applications or something?
Let's see. Refactoring code. Working effectively with legacy code. It's the Michael Feathers book. Really good. It'll actually kind of show you how to take an existing system and slowly bite away at it until it's kind of easier to work with. So I recommend that one. That's one more time. That's Working Effectively with Legacy Code by Michael Feathers. So
Yeah, and my strategy has been, because I actually do work on legacy code in my day job. My strategy has been in the past, like I let change drive where I need to, where I start adding unit tests. Like for instance, if I get a ticket to work on some legacy service deep in the application, that's what I'll say. Okay, well, if I'm changing this, I need to write a unit test for it, and then I'll let that drive the decisions. The decisions, at least, of what I test first. How you approach it, that book is going to be hugely beneficial to showing you how to
Mm.
do that. Real quick, before we dive into the next little bit here, we're almost at an hour. I wanted to drop the giveaway link in the chat one more time, and also ask you guys if you could just invoke that like button if you haven't already. Just got to do that whole YouTube spiel. But for those of you who came in a little later, we're giving away a copy of Quantum Console. And that's a really cool asset for Unity. I have a video on it. I should have had a link prepared for that. But if you go into my channel and look up Quantum Console, actually, probably if you just look up Quantum Console on YouTube, I might come up as one of the top hits. Check out that video. It's a really cool asset. If we have time, maybe I'll show you guys about it. All right, so the next piece here is I actually had to make a modification to eye movement's signature in preparation for that grid-based movement. So this is just kind of show the advantages of being able to very quickly make certain design decisions a little much easier way. So with the grid, I wanted to be able to update. I know I'm going to have to update the grid first and then get the destination. I don't want to do it all in one shot. With physics 2D movement, it's all kind of in real time. I do the raycast and I get the destination. But in this case, with the grid, I need to do some logic on updating the grid, and then I can get the destination based on what the new state of the grid is. So that kind of makes more sense to me because I had already thought this through. But basically, just a very simple change. I refactored this so that I'm updating the position. And then finally, I get the position. So all I'm doing is the logic just updates a local private member field called position. So that's what happened there. And again, I have my unit tests, so I'm able to rerun those tests and confirm that sure enough, it does work. And if we go to my sheep class, the only difference here is that I call movement.update position, and then I get the destination after calling that. Another cool thing is I implemented the null. What is it called? Oh man, I'm brain full.
Null object pattern.
Null object pattern. And Jason actually shared a cool idea about this. I guess the naming of it, or actually putting it into an instance variable. But just to really quickly tell you what that is. With Unity, you don't want to throw exceptions. You don't want to be doing try catches and things like that. You just want to, as to the best of your ability, handle any cases or situations that might throw an exception. So in this case, what I've done is I try to get an eye movement component off of the game object. If one does not exist on it, that means that it was misconfigured. So the person who was setting up this Unity project was unaware that sheep require some sort of eye movement on the same game object. So in that case, what I've done is I've created a null movement implementation, and it doesn't do anything. So if we click and look at that, it implements eye movement, and literally every time you call update position and get destination, it just logs a warning saying, hey, movement has not been assigned to this game object, which this is probably overkill to be honest, but it's going to blow up your console with messages saying, hey, you have a sheep that doesn't have movement. And then that's it. That's all it does. Then it logs another warning on the awake. And the idea here is we don't want the game to fail and throw an exception, but we do want to, let the developer know that something has happened, something is in the wrong state.
Yeah. So to put things in sort of a real world perspective of that, we have in reality. You may think we do, but we don't really. So the example of this would be if you walked into a house and you went into the living room and there was no couch there. The difference is if there was no couch there, imagine from a programming perspective, the fact that there's no couch there causes a black hole to appear and the entire world gets sucked into it. That's what null is for an application. It doesn't just mean there isn't something here. It means this has broken the fabric of the understanding of how this entire application works. There is an absence of anything, and that can be very scary from an application perspective. So when you're doing something that it's not mission critical if that thing exists, sometimes it's easier to just have not a couch. there instead. Or couch where it is a couch, but the flag of can sit on it is false. So the idea is imagine an empty rectangle where it doesn't have any affordance for sitting and can sit on it is false. It's not really a couch. It's where a couch should be, but you've managed to forgo the black hole problem by just putting something there that conceptually is the space where the couch would have been. And so that's what a null object is. It says you can either propagate this idea of this little time bomb through as if anybody ever tries to access it and it's not there, the whole thing explodes. Or you can once assign this value to, well, here's a version of it which doesn't do anything. And that just means for the rest of your entire application, you just treat it like it's already there. And then only one place is that ever dealt with as oh, I'm not really there, so I move on. Now, personal preference, I don't like putting log messages and stuff in my null object, because to me, an implementation of a warning logging movement is a different implementation than a non-implementation, which should literally do nothing. But semantics, like at the end of the day, it comes down to when a case would normally be a null object, if it's easier to just assign it a blank object, the rest of your code will be a lot cleaner, because you just don't have to worry about passing this nothing concept around the entire code base.
Yeah. I didn't even realize this exists. Bockerell says try get component. I didn't know that it was a thing.
Yeah, you can even do var out var underscore movement and not actually cache it. You can use it as a single inline.
Oh, gotcha. Yeah. That's cool. Well, I didn't know about that. I use this, I guess you can call it a pattern, quite a bit now. And so I know that, Jason, you created something called like requires component or what was it?
Require, just so basically I had object.requires and then this, and that way it basically wraps it.
That's cool. I gotta maybe that could be a video one day.
Here, let me send you the script for a second so we can see what people explain what we're talking about.
Yeah, and Bockerell mentioned also that I should use a POCO here, and I agree. I don't even know why I made this a component.
Don't worry, I already called him out on that before.
Yeah.
So there we go. That's the version that I would do for pretty much a similar, because I'd find there's two stages. There's something that's required at the start of an application, then there's a null object that I can pass in as a proxy.
Let me open this up here. Can I just drag this in?
Probably.
Very nice.
Yeah, so here's a small example of something that I would do in a lot of projects, which is this basically says for every single object in my project, which extends from a Unity object type, if I just call .requires and pass in a type, so require, so I would say I could then pass in the object it's on, the mono behavior, and it will log a message and say, hey, this mono behavior requires this object, please assign it. And it's the same thing. It just means that everywhere in my code base, it'll show me what the object is, what was missing. And if I click on it, because I'm using the overload of the debug log format, it'll ping it in the hierarchy. So by having this one line, I can just write requires, and it'll just mean that I don't have to worry about the rest of it.
No, I'm going to copy that. I totally missed something. Oh, I missed the whole class.
Yeah, it has to be a static class for the extension method.
Oops. Yeah, I totally missed that one. For some reason, I read that as a namespace. All right.
Oh, that's system object, you need Unity object. Yeah, there you go.
So now we can basically replace this. Require.
Yeah, so you would say sprite render. So yeah, you'd require the sprite renderer.
Got to spell it right, of course. Requires.
Well, it's on the object, so say underscore sprite renderer.
Oh, it'd be movement.
Sorry, underscore sprite render. Yeah, whichever you dot require this.
I'll do the sprite render first though, because I don't.
Yeah, require this.
Okay.
So it reads like I'm saying require the sprite render, even though conceptually it's actually working the other way around, but that's just because it works easier for me that way.
Do I because
it's only for types that extend from Unity types that it can log it.
All right, got it. So
you get the idea.
Yeah, I get the idea. That's cool. Would there be a way to make that work for the interface? Like, no, right?
Yeah. If you copy the function and remove the casting for see where it says where T is object.
Got it. Yeah.
You can remove that. The only reason I have where T is object is it allows me to do where is it? In one of the places. Actually, just get rid of it there. Get rid of the T's object cast. That was just for it was mono behavior types. And I'm curious, am I not? Yeah, I'm not referencing anymore. So yeah, that'll actually work now. I was just using it expressly as a Unity thing.
Got it. Still complaining about it, but
Oh, because it's Unity object. Sorry. So change it to just object instead of Unity object.
Oops.
So,
I got to do it on mine. I was doing it on yours.
So it's object context in this case. Oh, right.
Let's see if that works though. Yeah, there you go.
Never code live.
Yeah, I know. This is why I prepare commits ahead of time. All right. You guys realize how bad of a coder I am. All right, well, that's cool.
So the TLDR is, I would use that as a, like, if I've got an awake function, I'm grabbing a bunch of stuff, I would use that require concept. And then once I find out something is null, I would just say, if it hasn't been provided to by the user, set it to a no version of that object. And if you combine both of those concepts with a lazy loading concept, you can basically have it all automatically happen. And it'll only try to load the object when it's needed. And then if it's not there, provide a default implementation and log a message to the console.
Yep. Cool. All right. So I think we're finally ready to get to the point where I actually implement grid-based movement. So let's look at this commit. Implemented basic grid-based movement. Let's do it. Switch on over to Unity so this thing can reload. And I think I have my fancy level in here that I created after watching that video. Yeah, look at that. Press play here. Uh-oh, not moving. Probably have to actually update the... do I have a grid? Well, we can figure out what the story is there. Let's look at the code. It's like I'll run the tests and they'll all pass, but it's like it still doesn't work. All right, so if we go... No, go ahead.
I was going to say, and even though the level doesn't look like there's a lot in it, we can give a really fun rundown about the massive amounts of subtle complexity that have gone into just a little decision.
Yeah, that'd be fun. That'd be fun because, yeah. All right, so you can see here that nothing has changed on Sheep. I actually haven't. If we look at the commit, all that I've changed here is I've added grid movement, which is that implementation of iMovement. And then, of course, I updated my world and I made a player prefab. But if we look at the grid movement, basically, let me open that up actually, not the diff. Grid movement. We can see that it implements update position and get destination. Okay. And so what it does is it has a serialized field. So it has reference to some grid. And then on start, it makes sure to capture its current position. And then it sets the grid. The grid basically has an indexer that takes in a vector 3. And then it sets that to 1. So I'm using the grid very rudimentarily right now, in that if there's a 1 in a position, I'm seeing that as it's blocked. I can't go there. And you could see that in the update position. I say if grid next position equals 1, then just return. So what that'll do is it'll make sure that the position just stays the same. So as you can see, it says next position, current position plus direction. Then it checks, like I just said, if there's something there. Otherwise, it's going to set its current position to 0, meaning it's freed up, and it sets the next position to 1, and then it's going to keep track of its current position. And then if you look at the grid, it's nothing fancy. It literally has a width and a height, and that's it. It's just an int array, 2D array, and again, I have that indexer that just takes in a vector 2 position and determines what the cell is. So if we go back to the Sheep class, I'm trying to figure out what I did wrong here. Oh, I think I know what it is. Or maybe I don't.
Well, one suggestion was that I thought you pulled a different commit, but if it's the same one, then the try get component is inverted possibly.
Oh, okay. Fair enough.
I assumed you'd forced a different commit.
I probably... oh, somehow it stayed. Right. Okay. Thanks, guys. Live coding. Hey, look at that.
There we go.
Now we're hopping all over the scene here. And then if we go and run the test, if I didn't even want to play the scene, I think I was watching a Jason Wiseman video the other day, and he came up with a really good reason for use it why you should write unit tests in context of Unity. He was mentioning that like you might have some sort of creature or thing or enemy that only appears on like level 8, and
you don't have to play to level 8 every time, yeah.
Or you don't have to figure out some way to like force your game state into level 8. Although that's nice to have, but
that's actually something as well that I highly recommend. Is I was working on a little project, and if you were on the Discord, you would have been able to grab a zipped copy of it. One of the things I did with that is it's additive scenes. So there's one scene that covers the player and its basic lighting, and there's one scene that covers like logic for the UI and for fading and menus and that kind of thing. And then there's one scene that would handle levels. And the benefit of this means I could open any level, which has no complexity in terms of sort of the sun or the lighting or the character controller or the camera or any of that. And I can just additively load the player scene, press play, and my character is just in and playing. So that means I need to be part of this life cycle of working my way through it, right? So for testing, it's almost always a good idea to try to make your game playable potentially from any scene.
Yeah.
Now that may only happen for you, but as you move on and you start adding things like a debug console and whatever, it might be nice for you to give yourself an ability to jump to a certain level. And that's not just like a random indie tip. For an example of this, if you watch the Doom Eternal speedrun, there's a common trick for that, which is there's a debug dev room somewhere on like one of the, I think 5th level or something like that, where you can clip through the wall, which you're never supposed to be able to do. You get up to this dev room, which gives you like all of the guns, all of the armor, and portals to like 3 or 4 places in the level. So even the pros do it. So give yourself some method of testing at different places,
This is something that I'm curious about, because I was thinking through this game here, and I think what I want to do is like whenever the sheep gets to the end of the screen or gets to the place where he can move, like it kind of fades in and fades out to the next part of the level. And I was thinking, like, should I fake all that? Should I have this whole thing contain my entire level, and every time you get to some boundary, it like does a camera fade? Or do you think I should store every single individual one of these positions in the world in its own scene?
I think in its own scene is a bit overkill, but if you ever got to the point where you had sort of biomes or sections, I would say that you could probably have like 10 to 12 screens per region or biome. Basically, what you want to do is give yourself enough time that you can traverse across multiple screens, and that gives you a good indication of direction. So, for example, if there's a middle square and there's 2 squares either side, if they're moving 2 squares over here, you can safely unload everything over here, because you now know that it would take you time to get back. And likewise, you can start preloading this area here. If you've got individual scenes, you're doing a lot of loading and unloading. But if you've got enough bandwidth that you have to force them to move upwards in a direction, and you'll have enough time to figure out when they're going down the other way, you can load that later. There's a great talk from the Firewatch team about how they used sector streaming for their version of that. But their effective thing is that they have additive scenes that represent large chunks of the area. And then what they do is they then split that up into the art logic pass and that kind of stuff. And then they would use low poly versions of the background stuff at range. Once you get closer, they would unload those and load the higher one. And there's they'll go through it in vivid detail about how they do it. But in essence, it boils down to, you should load the next area when you know the player can't go back to the old one, and you can safely guess what direction they're going in.
Right.
So I personally would go, whatever it is, 6 by 6 or something, or 9 by 9, whatever it is. You would just pick a size grid, and then you'd have associated regions.
Right. Yeah, because one thing I was thinking was along those lines is, if I designed every one of these scenes to be a little, I think this is like a 10 by 16 chunk of tiles, then I could additively load all the ones around it. And then as I'm moving, like you mentioned, like, okay, I'll unload this one. And then as he gets all the way over here, it unloads this one. But yeah, so for me, what I was approaching it is, what would be the easiest way for me to design levels? Would it be easier for me to just compartmentalize every single level into a scene and I can just create them individually? Or is it easier for me to say, okay, I'm going to just design a big ass...
Well, you can still compartmentalize each one into its own prefab, and then stack all of the prefabs into the scene. And then later on, when you decide what level loading solution you want to take,
oh man, I love it.
How many prefabs build a scene, and how many scenes additively build a level.
Designing for change, man. That's what I'm talking about. Not just code. That's good. That's actually a really nice solution. I like that. Thanks, Jason. This is why I keep you around.
No problem.
All right. So, all right, that's the end of it. Basically, we got to, we did it. We encapsulated the code into an interface, and now I implemented a new interface, and I have grid movement. A curious thing. Yeah.
Sorry, no, go ahead.
Well, I was going to go into the next part. I had 2 more commits that I did, and I actually introduced a bug. So I was going to show how I responded to that bug. But no, what were you going to say?
I was just going to say, just to kind of highlight the summary lesson from all of that is, we've got to the point now where there was an old method of moving. There is now a new method of moving, but we haven't lost the old code. It is there as an option to switch back to. We've not subtracted from it. So the idea is that we've implemented multiple variant solutions that can be implied. So in this case, we're using grid movement, but we could go back to it if we wanted to. And this can be a big issue when you're not familiar with some of the stuff we were talking about, which is you'll write code, you'll get frustrated that it's not working the way you want to, you'll rewrite it, you'll realize you've gone down a large rabbit hole of stuff, and you get angry at yourself and go, oh, I'm just going to go back to the old version. And then you realize, oh no, I can't go back to the old version because I don't have either a backup copy of it, or it's going to take me, I'm going to have to undo like 5 other things because I've not been committing on a regular schedule, or that was 7 commits back. So if you, instead of completely rewriting an implementation, you encapsulate that implementation as a strategy and move it out and put in a different strategy, you can literally swap out that one line and you get back the old behavior that you had before.
Yeah.
And so that's what we talk about when we say designing for change. We know it's going to change. So rather than kind of pigeonholing ourselves into one implementation, we design in such a way that we can take some change out and put a new change in if needs be, you know?
Yeah. Yeah, that's a good point. So that's a good summary. And a good place to kind of just move on real quickly. Wanted to show you that I was going to do the same thing in the sheep for this transform do jump. I figured, well, something like updating the sprite, doing this animation, that will likely change as well. What if I don't want to use do jump anymore? What if I will have a different type of creature that's like a fox and they don't jump, they prowl or whatever the case might be, or if I have NPC farmer who needs to walk around, they're not going to be jumping. So I thought, well,
in my case, if I share that code, I don't like having the do tween dependency. So another advantage of separating that out means you remove referencing to do tween in this script. You can create a really basic implementation which just uses a coroutine, or even just moves it using the normal vector position. Then you can add your assembly definitions, and all of a sudden you can take out the entire core of your game, give it to somebody else, and they can choose to implement it with iTween or whatever else, or Surge, and it's not going to, they don't have to gut out references because you've removed those strategy implementations.
Right. So in this case, what I wanted to do was do the exact same thing we just did, move this logic out into a class and then start to pull that up into an interface. So if we look at the commits here, you can see that I encapsulated sheep's movement handling logic. So we'll go ahead and check that out. And I actually introduced a bug, so we'll take a look at that. Go back to the Unity so it can recompile. Okay, we're good there. So we have this movement, this sheep movement handler is what I call it. I'm doing the same thing as I did before with the null check. And then you can see now all my code does is, because I don't know why I did this twice, but because I hadn't made the null object. So at this point, it technically could still be null. I do a log warning, but in the case that it's null, I just want to do nothing. But if I actually do have it, and I know Jason's going to tell me to do this, do a guard clause.
Yeah.
So we'll say this is a guard clause. So we're going to say I have no logic after this routine. So I can safely say if it's null, just return, don't do anything. Otherwise, let's call on move on the movement handler. And in this case, I'm going to pass in a direction, a destination, and a lambda. And the lambda is just going to allow me to update the sheep to let it know that we've stopped moving. Right. So some of you might already see the bug. So if we go into the on move, again, just like we saw before, I'm updating the sprite, I'm doing the do jump, and that's it. It's nothing's different. However, there was a bug. So if we go in, let me see if I can show you that bug. See if this loads correctly. Go to my player. Make sure I add my sheep movement handler. All right, let's see. So we can see here that I moved. You saw that? But then afterwards, I'm not moving anymore. I'm still pressing the key. I only hopped one space, right? So what the heck happened there? So I needed to fix this, and I didn't know what the story was. So the first thing I decided to do was write a unit test. All right. So we go to my commit history, and so you can see it's fixed a bug that caused sheep to only move once. So if I check that one out, we can see that I created a test in sheep tests. See if I can find it.
On a side note, one thing you're going to have to do at some stage that's driving me insane is you've got sometimes you're using if with the bracket, sometimes you're not, and there's no consistency.
All right, so basically I say can move multiple times. That's the test. So I create a sheep, and you can see that builder method that we created.
And by the way, we didn't actually discuss why a builder is important here. Basically, the benefit of a builder here is rather than using a constructor, this comes back to the thing we talked about earlier. If you construct your object using either a constructor method or an initialize function or something, you've got a contract there. You've got in order to create a sheep, you need A, B, and C. These are the 3 parameters you need. And if you go ahead and change that later, you will add a 4th parameter. And all of a sudden, every single place you've ever created a sheep in your code has a new parameter to pass in, and you'll have a nightmare going through and having to update all of them. The thing about a builder is you basically say, create a sheep, and there are variants of the builder where you have create a default sheep, create a jumping sheep, and you create the built version of that. And that way, the intent of the test is give me a version of this pre-configured to be this. And that way, if the implementation of that configuration changes, it changes in the configurator, which is the builder, not in every single reference beneath it. And this allows you to very quickly say, take a prototypical version, but swap out these 2 parameters, and then make another prototypical version, swap out these parameters. And it makes the tests cleaner because you're not saying plumb the same 10 things. Like every sheep needs an ID, and every sheep needs a color, and every sheep needs a sprite. Like you can just say, create whatever the default for a sheep is, but these are the only 2 parameters I care about, swap them out and move on. So yeah, that's the predominant reason why you'd use a builder.
They call those test fixtures is the concept, and basically your fixtures are things that you have agreed upon as being standard element classes that are configured in a standard way. So we know that we have a physics 2D movement, a sheep with physics 2D movement with a sheep movement handler. We might say, hey, this is our standard sheep. Let's go ahead and call that a default sheep is how I might call it. So it makes the code much cleaner.
And the thing too is people get very kind of worried about writing code in tests. They sort of feel like, well, the tests are there to test my code. I can't write code in tests. And that's kind of a silly thing when you think about it. In real terms, tests are code as well. Now it gets a bit circular to think about testing your test. That's a bit nuts. But what I will say is you are allowed to write code to simplify your tests. Yeah. So if there is a particular thing you're doing a lot, just wrap it in a method name, just as you would to clean up your code normally. In this case, these are all very clean, small tests. So
I have this one here, create obstacle.
Yeah, exactly. So
for my obstacle tests.
There's a bunch of steps that need to be done, and it's perfectly fine to simplify your test code. So don't feel too worried about doing that. I notice a lot of people are very reticent to do any kind of testing code because they're just afraid that it's like breaking the rules. What if I have bugs in my test code? Well, you have to fix that. Make sure that your other tests work. Like eventually you'll kind of circulate onto the solving the problem.
Yeah, that's a good point. So so I wrote this, can move multiple times, just creates a standard sheep here, does a for loop, calls sheep.move twice. And then, we'll see that we won't see because I fixed it, but it basically failed. And then I was in a better position to go to my sheep class here and actually figure out what the problem was. And the problem was I was actually setting this to true instead of false. And so that, I figured out that was what the problem was. No big deal. Fixed it, ran the test. It passed. And I didn't even have to run my scene to know that it worked.
Yeah. And that's the other thing too. Here's another subtle thing about that. If you've got a test suite and you have a bug to do with movement, you can run your tests. And if all of them pass except for 1 or 2, you've immediately localized the problem to the stuff that is touched by those 2 tests. Yep. And that's one of those subtle benefits that you don't really think about. Is if you had a problem where you had a character who's like a rigid body moving around a scene and he's interacting with stuff and swinging the sword, and something goes wrong, character starts like wobbling or doing some weird stuff, you're like, this could be the animator, this could be the movement system, this could be the rigid body collision, this could be maybe I'm using some weird soft body physics. Maybe there's issues with some objects themselves. Things that could be wrong. But if you've got a test suite, running some of the tests will at least let you know, well, at least it's not that stuff. And you'd be amazed how just that one step will cut out like 3 hours of testing and turn it into, or 3 hours of debugging and turn it into like 10, 15 minutes, because you don't go down a bunch of rabbit holes of, well, it's probably this thing. So just having those tests lets you sort of say, at least I know it's in this class somewhere in this function. And all of a sudden, like, you're not hunting around your code base.
Yep. All right. Well, that I think about wraps it up. I think we've shared some pretty good strategies here. Do you want to look at that level and talk about some of that?
Yeah, let's just finish up with the levels. So this is a little bit tangential, so I don't know if this interests anybody. But
before we do that, hit that like button, and I'm dropping that link one more time for the giveaway. So be sure to sign up for that. All right.
So up to this point, we've been talking very code heavy, but there's a lot of other stuff to do with game design. And if you remember that opening graph thing that Charles showed, that was just some of my thoughts on some of the topics that are relevant to game design. And so this was really interesting. So here's the thing. We've all been there where you end up with a blank slate. What's really frustrating is you start putting some stuff down and it's just not very satisfying. It doesn't feel like there's anything to do. There's no real point. Like, why am I doing this? Or your levels just don't feel like a fun place and you can't really figure out why. Well, one of the first things you should think about when designing any kind of level or scenario is you want to give the player an objective or a goal. And that may sound obvious, but when you create a scene, even if it's just a prototype demo scene, make sure there's something to do. Now, if that's the first thing is, if you launch the scene, you've never played this game before, have no idea what it is, there's this concept of affordance. So a chair, afford sitting on it. Its shape, its design, the way we know about chairs implies they're sittable. That's the thing they are. Same with benches. You may see a weird artistic bench at some museum. You don't know what it is, but you get a good sense it's a bench, right? You know you can sit on it by the shape of it, by where it is, by the location on the ground. It gives you a lot of information by proxy. The most common example of this is a door. The door handle, grab it, and the implication is you pull it to open it. But the problem is, if you see a door with a handle on both sides, it can be confusing to know whether you push or pull. But if you've got a door, which is a handle on one side, and it's got a little rectangle panel on the other, that implies the affordance of that is to push it. So effectively, long story short, whenever you've got a plank of something sticking upwards, the affordance to that is it's a sign or it's readable. And we all know this. This is an intent, like whatever it is, it's a readable thing.
Right.
So even if you just look at the scene and you know nothing about this game or anything about it, your intention is, I want to go over there and read whatever on the side. Now, if there's anything at the moment, the implication is, if the minute the project starts, the first thing you're going to think is, I want to read what's on that sign.
Right.
That's just what you're going to do. And so all of a sudden, it's come from an empty scenario with nothing to do to like, oh, there's a point to play this now.
Yeah.
Before I even press a button, I have an objective. So that's step one. The second thing is, there's this whole concept of these bushes over here. Now, this is another one of those things which has an affordance applied to it. Now, you don't think about it, but because of the position of them, they're basically abnormally placed to everything else. And there's this particular pattern of matching branches with a space above it. That's very, very clearly alluding to this space up there. And I think anybody who's ever played a video game will probably have a clear indication that you'll get some cut ability at some stage to be able to get through those bushes.
Yeah, that's one of the things I wanted to articulate with this too, is that in this part of the game, you would not be able to attack those bushes. But very shortly after this scene, my idea was you'd be given the ability to cut bushes. You'd cut bushes in some other area, and hopefully you'd remember, oh, there were bushes where I started. I need to go back there.
Mm-hmm. And so there's other levels you can attach onto this. So one of them is that sets up anticipation. So the idea is players have anticipation of going, ooh, there is going to be something interesting up there. I will keep this in mind. And if later on I get a cut ability, I'll be intrigued to come back and check it out. So that's all in that one little scene here. We are enticing the player to go right. We are telling them there is something to go up, but there's nothing there yet. And very clearly we're indicating we can't interact with that. And then later on, you can get to this concept called one-way valves. And that would be where you move them along to an area where they can't backtrack anymore. And you'd cycle them back around, and they might end up cutting that from the top down. All of a sudden, it's the reveal of, aha, I'm back in the original area. That makes sense. It all interconnects now, and I've made a shortcut to some other path. Zelda does this a lot. Like, there's a lot of these concepts that are baked into how they're designed. And so there's a lot in this in terms of how do you make even a small thing like this compelling. But for a shorthand, if you just look into level design and look at concepts like and signifiers, you're going to get a lot of surprising information about just really small situations like this. So yeah, there you go.
Cool stuff. Yep. That was good. That was succinct, and I see Vakaro mentioned something cool.
Yeah, the Gestalt law of grouping. So that's basically things that are grouped together. That one in general, human beings like seeing things naturally grouped. That's just the thing that we do. Like we will find patterns, but things that are grouped in pairs are always more interesting. So if you had a scene full of equally placed stuff versus a group of 3 and a group of 4, we imply behavior to things that are grouped together and are like effectively. So there's a lot of interesting. There's also this whole concept of differentiating shapes. Larger to smaller implies different behaviors. So having large blocking structures with smaller interactable structures is very clearly a pattern here. There's a whole load of this stuff. Like you can go into this for days.
I even went so far as to make sure that there was like thicker grass in the areas, just to kind of make sure that the player knew that these are the areas you can go. There's like an opening down here, but I don't intend for the player to be able to go through that. That isn't something that is like you can diagonally move through. So I may have to do more work to block that, but I'm hoping that at the very least I've afforded, maybe some player would be like, oh, I'm going to try to break through here. But realistically, I'm trying to communicate that you're not supposed to go down here. So cool. Great stream, guys. Thank you all for coming out. I hope this was beneficial. I know that, we're not going to have a video tomorrow. I didn't mention that, but hopefully.
Actually, by the way, one last note, because you did bring it up just at the end. You just reminded me. Another interesting topic about what you said there with that little gap. An interesting topic a lot of people don't think about is when you're blocking areas, there's the classic problem of the invisible wall, right? You're blocking an area you don't want the player to go to.
Yeah.
Well, there's a kind of a degree of barrier. There's hard barrier and soft barrier. And effectively, what people don't realize, one of the best kind of soft barrier you can produce in a game is to make the place not interesting. You don't actually have to block it. You just have to make it visually not something interesting. And the only problem is right now, those stones do make it interesting.
Yeah.
But if you didn't have those stones, no one would really think to go there because there's nothing in telling you to go in that direction. And so you'll find this a lot if you watch... look at there's tons of places where the game guides you in a direction without any visible walls, because what it's doing is it's guiding you towards light and interest and stuff going on, but there's entire other swaths of the game where there's just nothing going on, and you can go down some corridors and go down different routes, but the game just doesn't want you to go there. So rather than actually gate you, it just puts nothing interesting there, and it makes you just less interested in going there.
There you go. No more rocks.
There you
go. Cool. All right, guys. Well, yeah, again, thank you all for coming out on this Saturday. No video tomorrow, but please feel free to sign up for that giveaway. Again, I'm going to announce a winner for that next week, either July 4th or July 5th. And then we should be back to weekly video. So July 5th, look out for that. And yeah, other than that, have a great week and catch you guys later.
Good luck, everybody.
Cool.